Welcome back. As this channel has covered the performance history, most of the previous content was covering the small block Chrysler. So it doesn't seem like any of the intelligent minds within the performance industry have necessarily been found. We're only going backwards. Now, this goes back to a video created over 4 years ago. Issues that engine builders have been experiencing since the late 1990s, and that's within the hydraulic flat tappet mechanical components. Now, what has been, this is fact, this is what has been happening within the performance industry, within the engine building arena. Your hydraulic flat tappets, whether it's through the metallurgy, the machining process, the mating surfaces, between the camshaft profiles, the lifters, there has been a complete failure within those components. The hydraulic flat tappets cannot be trusted. They've wiped out multiple engines. Now, why is it just the hydraulic flat tappets? Why are we seeing failures within solid flat tappet engines? Okay, it's a question for any of you engine builders out there. Why haven't we seen that problem? Is it because of the additional room within the lash specifications of solid flat tappets? So basically the entire industry and your average garage builder or do-it-yourselfer has been to avoid going to hydraulic flat tappets and then immediately going to roller systems. Okay, any of you engine cam professionals out there, you can add in your own little comments and opinions, but this is facts based off of what is actually occurring. We have 20 plus years of evidence to prove exactly what's going on. During that time, we've had multiple things change within the construction or statistics in hydraulic flat tappet mechanisms. Whether it's the camshafts wiping themselves out because of the hardness of the lobes, to the angles being ground into the lifter faces, the plunger aspects. Now, you don't have to necessarily take my word for it. Again, it's been something that's been discussed on YouTube and content creators for many years, over 5 years now. Well, we're seeing even recent builds being done by very reputable individuals introducing even an additional problem. Now, it's not just connected to the hydraulic flat tappets. It is now something being observed within the hydraulic rollers being used in small block Chryslers. So to understand the problems, I have attempted to instruct individuals why the failures are happening, even with factory equipment like the Hemis, the hydraulic flat tappets. They're the reason for some of the factory recalls that have gone on because of the oil and tolerances built into the mechanical devices. One thing that separates the small block Chrysler or the Hemi Chrysler packages is the angle of which the lifter bores are at to the cam center line. Now, for all of you Chrysler fans out there, it's the small block Chrysler, big block Chrysler, and the Hemis. They all share this altered angle. So the two organizations I'm going to name out today, one is a YouTube content creator, the other one is a YouTube sharer. Engine Power is a televised broadcast. Okay, it's something that's found on YouTube, it's found on Facebook, it's found on pay-per-view, it's found on certain TV stations, so on and so forth. They just completed a 318 build. Now, in a previous video, I stated that their initial blueprinting of the engine went through and they did everything they possibly could that they've duplicated on any other engine, and immediately upon break-in on the engine dyno, they immediately found that power numbers came down. And I directed it saying that their initial oil pressure was above 70 pounds. That should have been a red flag right there saying that something is wrong. The tolerances are way too tight within the engine. So they started the engine up, let it warm up, and they did their first dyno pull, and it created approximately 430 horsepower, in that range. Okay, not exact. The follow-up dyno session lost approximately 60 horsepower. And when, after removing the oil filter, they found all kinds of oil particles in the filter element. They immediately abandoned the project. Now, I'm sure they're diving into it, and their TV crews are starting to investigate. They're going to go through and find out exactly what bearing was wiped out. Okay, yet to be determined, but we can predict. Those in the engine world can predict exactly what happened. Okay, the tolerances were way too tight. Going back to a video that was released by Likens Motorsports approximately a year ago, of where the tolerances between his piston to wall clearance was very tight. Okay, in that same situation, the break-in period, the runtime made the engine lock up. There is not enough tolerances within the mechanical devices in today's practices. The oil, even though it's a lower viscosity and a thinner consistency, it's meant to get into those tighter crevices, but it does not provide the protection between the mating materials of the combinations. So I don't care what individuals agree with Lake Speed and his $1 million complexes to carry out the test of oils. They are not providing the protection needed for performance applications. Again, you can disagree with me whether you follow NASCAR or anything like that. The components are being designed to work without the dependency on oils. The oils themselves are only there for a cooling liquid. They're not necessarily there to be the lubricating property, especially within Formula One. Formula One leads in technology that is adapted by every other kind of racing or performance industry that is also duplicated. So stuff that's found out in Formula One is then shared with NASCAR. And between that observations, they're shared within drag racing. And then that works its way down throughout the entire performance industry, even your do-it-yourselfer. Now, one thing that was very similar between the engine power and the Bowtie Man here on YouTube, they both built the 318 utilizing a specific hydraulic roller lifter. Now, in the Bowtie Man video, he's complaining that he cannot remove the lifters without removing the cylinder heads because the lifters are so long that they cannot extend out of the lifter bores enough without hitting the cylinder heads, and it's the connecting tie bar that interferes with them coming out. So to avoid having to, disassemble the entire engine, he's trying to fix it while it's still in the engine, and he's finding out that the plungers in the hydraulic rollers are failing. Something that I pointed out 4 years ago with the hydraulic flat tappet lifters. It is actually the plungers to the lifter body tolerances that are not allowing them to pump up. So it's a hydraulic problem, not a solid lifter issue. Now, what is dependent in a hydraulic lifter compared to a solid? What is dependent to allow those systems to function? It's the internal components, okay, and the oils. So no matter what your belief is or what you've been able to back up in different tests, we can narrow it down to the actual issue. It's not the cams. It's the lifters themselves. Reinitiating what I've been saying for 5 years now, that it's the flat tappets or the hydraulic lifters, whether they're flat tappet or roller, that's causing the issue. The oils are not designed to work with the tolerances within those systems. So this goes all the way back from my first experience with wiping out an engine with a hydraulic flat tap end engine, 318 to be more specific, all the way back to 2002. From that point on, I'm going to guess that I built over 700 other small block Chryslers knowing that same issue, requiring the disassembly of every single lifter and checking the tolerances. And I will tell you that at least 7 out of the 8 lifters, 8 out of the 16 lifters have failed with inspections, no matter who I got them from. Most of them receiving plungers that are too small to allow the oil to bleed off to where they won't pump up, or tolerances so tight they will not allow the lifter plunger to actually be compressed. That's going to affect how the mating surface is between the lifter face and the cam lobe. It's going to wipe them out no matter what angle you put at them. Now, going back to the Engine Power and the Bowtie Man YouTube channel, building the 318 with these newer hydraulic lifters with the tie bar, they're so tall that they can't be exited from the block without removing the cylinder heads. They're also so tall that it changes the angle of the actual push rods inside the cup to the rocker shaft. So hopefully you guys can understand that the angle that the lifter bores at in Chrysler is laid back even more, that it does not give you a true a true inline direction between the actuation of the lifter through the push rod to the rocker. It is changing those angles dramatically. The longer that lifter is, or how much farther up the plunger is during the initial break-in, the greater the angle is being placed on the push rod. Even the design of the push rod, whether it's a double ball end or a cupped and ball end push rod, is starting to get recalls, even in the diesel world, to where diesel applications that are using dual ball end push rods are starting to fail because the connecting surface between the ball and the cup of the lifter is failing because the oil is not being injected or pressurized through the inside of the push rod. It's only there for gravity to feed. And with a cup over the top of the ball end of the top of the push rod, they're not being lubricated at all. So it doesn't matter what oil you're using, they're failing. So now even in the diesel world, you can buy transfer kits to go back to the older style where the top portion of the push rod is a cup and the ball is actually in the the rocker itself. Okay, folks, it's the engineering behind the mechanical components and how they're working in conjunction with the oil. The tolerances and the actual engineering is wrong. Now, many of us are going to point out one specific part like I have within the lifters, but it's also the engineering of how the oil is being utilized to lubricate those components. The oil is associated with the failure of not only the flat tappet lifters themselves, but also the failure of the push rods and the rockers. So it's not just a single mechanical piece, it's oil, bad oil is associated with all the failures. Again, you can go into the massive recalls with General Motors. Some individuals are saying it's the machine finish of the crankshaft itself in conjunction with the bearings that has caused this billion-dollar recall. Folks, older engines that didn't have the technology behind the machining process or within the materials of the bearings themselves, the oil will still be able to withstand impurities or imperfections within the machining process. Engines still would, achieve 300,000 miles plus with even irregularities into the machining process. It can't be done with today's thinner viscosity oils. So the oils is in conjunction with all of the failures that we're seeing in the performance industry. So again, those individuals that swear by Lake Speed, you're idiots. You don't know anything. And Lake Speed, I'm saying it right here, he hasn't proven anything when it comes to oil technology. Nothing. Now going back to the angle of these lifters, again, they're hydraulic rollers. The taller bodies don't allow them to be removed from the engine without removing the cylinder heads. They're also increasing different angles onto the push rods where there's going to be more deflection within the push rods themselves. That deflection is then mirrored to how much the valve moves. So even though individuals have opted to go to hydraulic rollers to replace the issues that we had with the hydraulic flat tappets, they're not addressing the problem. With the increased angle to the push rods, it's also forcing down on the lifters themselves, whether they are pumped up or not, introducing more pressure to the sides of the actual lifters within the lifter bores, creating more friction. And the oils can't protect against the additional friction or closer or tighter tolerances. Something proven even with factory equipment within the engines of the Hemi family. The number one cylinder, the very front lifter, even though it's a hydraulic roller, with a spider hold down configuration, they're even having issues to where the tighter tolerances don't allow what oil does make it to the number one cylinder or to the number one lifter hole to lubricate it. And at idle, many of the earlier Hemi editions were wiping themselves out with less than 50,000 miles. Again, look at the height in the Hemi comparisons of the hydraulic rollers compared to the earlier solid roller designs. So if you're modifying a Hemi engine of today, do not get the aftermarket hydraulic rollers because they're actually worse than the factory rollers. The taller bodies required to run them, you might as well just jump into solid roller and keep the lifter body short to reduce that push rod angle. You're going to achieve more performance out of it. You're going to get less deflection. You're also going to have less weight. Because now going to this hydraulic roller design used by both Engine Power and Bowtie Man are lifters being sold by Summit and Jigs as performance pieces. And engines intended to go above 6,000 RPM. They're a complete failure. Who do you blame? Do you blame the manufacturer, the engineers behind it? Do you blame Summit or Jigs? Do you blame the individuals saying to use these pieces of equipment to replace former or earlier hydraulic flat tappets? Okay. In today's society, in the engine performance industry, you cannot put your confidence in anything that is hydraulically operated. The oils aren't designed for it. The engineers aren't designed the components for additional performance. It's a complete failure. Going back to a solid lifter, even in the more modern day Hemis, is a better option to go in hydraulic anything. Going back to the most consistent lifters that we've had in the performance industry yet is solid roller. And even solid rollers are starting to fail because of the less than desirable oils. Bushings and bearings are failing because of profile or how they're seating down. Even a bushing within a solid roller, the camshaft profiles, everybody's looking at the intake ramp side, how aggressive they can get, and not paying attention to the loft. Because again, with the newer oils, as I've stated before, you can take a hammer you can put a small dab of oil on, say, an anvil and drop a hammer onto it and see the spread and how much protection that oil provides between two metal components. Now, even just dropping a 5-pound maul onto that oil, imagine how much poundage is actually being produced by a running engine on the bearing surfaces. It's more than 5 pounds. And initially, Other channels have proven this too. You don't have to take my word for it. If your timing is off to the point where it hammers the rotating mass, you're going to have issues. Valve lash caps are required because of the hammering that's being introduced from the camshaft profiles onto the top of the valve. The push rods themselves are part of that hammering process. The camshaft profiles are. It's the aggressive nature of the intake profiles of the cam lobes themselves and avoiding what's happening actually on the exhaust side. It's hammering the entire system. The oils can't protect those metal components being hammered together. There's not enough viscosity. I don't care what detergent package or micro technology is behind it. There isn't enough compression protection. So again, it's doing your research. And it's not just turning to the so-called professionals today that are full of crap, trying to promote a product that is substandard to any previous product produced. Looking at the mechanical components and looking at the engineering behind it, what they're intended to work with. These hydraulic rollers being used in today, we have two examples by individuals not from me, two examples you can turn to of where they're failing. Because I'm going to make a prediction right now. Today is, Friday. I believe it's August 16th, 17th, something like that. 2026. Engine Power hasn't produced their video yet as far as what caused the failures of this dyno engine. They know that it's bearing material that was found in oil filter element. I predicted that the 76 pounds oil pressure they had, as they start up of the dyno, is a sign that the tolerance is too tight. Now I can guarantee, because they're using these hydraulic lifters, they also had consistency, just like Bowtie Man, that these lifters didn't have tolerances to where some of them were bleeding off and some of them literally turned into solid rollers without having the adjustability or the lash set into the system, increasing the oil pressure to the point where it wiped out rotating mass bearings, crank bearings, or rod bearings. The issue is the lifters. We know this for a fact because of the last 25 years of proof. So I'm not saying trust the science, because we've all seen what's going on with that. It's to look at the mechanical engineering aspect of it. The oil science is not keeping up with the mechanical engineering of it. And for over 100 years now, the hydraulic flat tappet lifter has been used. It hasn't been a problem found in it since approximately 2002. When did the oil viscosity start to drop? In the mid-1990s. So the issues became very clear at the early 2000s that it's the oil, not necessarily the mechanical components. The mechanical components are now being designed to try to work with the inferior oils. And it's still a failure. Name the actual issue. It's the oils and the tolerances built into the lifters of all of our performance engines. Recheck, check everything, and that means disassemble all the components and blueprint the lifters. All of them. It doesn't matter if they're solid or hydraulic. You have to take them apart. You have to check over every measurement to make sure that there's room for older, higher viscosity oils to be used in the build. You'll thank me later. Have a good one.